Dumelani once again, grade 11th, and we look at another example taken from Eastern Cape, November 2022, question number 5. It says an organic compound has the following composition by mass. They gave you the percentage composition, that is 54.55% of carbon, 9.09% of hydrogen, and 36.36% of oxygen. And they say that the molar mass is twice the empirical molar mass. In other words, the molar mass of this compound that is formed by this much carbon, hydrogen, and oxygen is twice the empirical molar mass. In other words, if we have, for example, the empirical molar mass being 2 grams per mole, it means that the molar mass of the compound is going to be 2 times that, which is 4 grams per mole. Then the first question says, define the term empirical formula. This empirical formula is the simplest whole number ratio of elements in a compound. The simplest whole number ratio of elements in a compound refers to the empirical formula. Then the next question says, determine by calculation the molecular formula of the compound. Now, how do you determine the molecular formula? You need to first determine the empirical formula. And once you've determined the empirical formula, you are then able to find the molecular formula of the compound. Let us start with the empirical formula. And remember, with the empirical formula, we said that if you're given the percentage composition, you assume that that compound has 100 grams. So 100 grams of that compound would give you 54.55%, which equates to 54.55 grams of carbon, 9.09 grams of hydrogen, and 36.36 grams of oxygen. So we calculate the number of moles of carbon, which is 54.55. Let me just start with the formula because I wouldn't want you to calculate without showing the formula. Don't make the mistakes thinking that that's the right thing to do. All right. The number of moles of carbon will be the mass of carbon over the molar mass of carbon. Let us do that quickly with a calculator. That is 54.55 divided by 12. Right, we get, that is 54.55 divided by 12, which is 4, I believe this is, I'm sorry, we are in load shedding, so I'm doing this in the dark. That is 4.55. So that is 4.55 moles of carbon. And then we find the number of moles of hydrogen, which is 9.09 divided by 1. Obviously, you start with mass over molar mass, which is going to be 9.09 mole. And then you calculate the number of moles of oxygen, mass over molar mass, 36.36 over, oxygen is 16, so that's going to be 16. Let me check that. 36.36 divided by 16 gives us 2.27. So that is 2.27 mole. Now that we've calculated the number of moles, The next thing we are going to do is we look at the lowest number of moles. In this case, that is the number of moles of oxygen. So we have carbon, we have hydrogen, and we have oxygen. Remember, the number of moles of carbon is 4.55, that of hydrogen is 9.09, and that of oxygen is 2.27. And we say that this 2.27 is the lowest number of moles, and therefore we're going to divide everything by that lowest number of moles, which is going to be 2.27 divided by 2.27, which is 1. And let us look at 9.09. 9.09 divided by 2.27 gives us 4, and that is 4. And 4.55 divided by 2.27 gives us 2, and that is 2. Now we know that the empirical, and therefore the empirical formula will be carbon. How many carbons do we have? We have 2. So that is C2. H, how many hydrogens? 4. And O, how many oxygens? 1. But since it's 1, we don't really need to write it here as 1. So we can just leave it as C2H4O. Now, we know the empirical formula. The next thing we're going to do is we're going to try, remember the question says we must calculate the molecular, or we must determine by calculation the molecular formula of the compound. So we have found the empirical formula. The next thing we must do is to find the molar mass of the empirical formula, which is C2H4O equals 2. We say that we have 2 carbons, 2 on the periodic table. Carbon, its molar mass is 12, plus 4 into molar mass of hydrogen is 1, plus 1 oxygen, which is its molar mass is 16. So let us do that quickly. That is 2 times 12, that is 24, plus 4 plus 16, that is 20, which is 44. So the molar mass of your empirical formula is 44 grams per mole. Now remember, in the question, they said that the molar mass of the compound is twice the empirical molar mass. So it means that the molar mass of the compound will be equals to 2 times 44, which is 88 grams per mole. So automatically that tells you that the number you're going to get, remember, in order to get the molecular formula, you need to divide the molar mass of the compound by the molar mass of the empirical formula. And that is going to be 88 divided by 44, which is 2. Right. So the number we get there is 2. And now we know the number that we're going to use in order to get the molecular formula. And remember we said that we have C2H4O. So this C2H4O, this number of atoms, we're going to multiply by that 2 there, 2 times. So it's going to be C, 2 times the 2 is 4, H, 4 times the 2 is 8, O, 1 times 2 is 2. And this is the molecular formula. All right. So that's how you get the molecular formula. You could have, however, skipped this part, and there's a whole part here, by understanding that if the molar mass of the compound is twice that of the empirical molar mass of the empirical formula, then it will mean that the number you're going to get there is automatically 2, because that's going to be 2 times the mass over the mass, and this will cancel that and you get 2. So you could have skipped the whole process. I just want you to remember the steps when you're going to calculate or to determine the molecular formula if you are given the molar mass of the compound. If they give you a certain value, then you know that these are the steps that you're going to follow. But however, if they say that it is twice that of the empirical molar mass, then you know that you could have just skipped all that to get to the 2. I hope that this was helpful. Let us be together again in another video. I hope this was helpful. Cheers.